What's up? It's Melton Metal Anthony here with another one for you. Today I'm going to be teaching Emily a little bit of the basics of flux core welding. Because she has a horse trailer to repair, I've been trying to kick in a welding lesson every time we work together. So what she's doing right now is cleaning her plates up. So there's the first thing you should know. Whenever you're welding anything, any process, you should always clean your material. We're going to go ahead, get the machine set up, and then she's going to start doing some welding. I'll show her how to do it. So if you walk into a welding shop to get a welding job, they might give you a test, something like this, where they would take two pieces of scrap, put them together in a T. So that's what we're going to do today. I'm going to teach Emily on this, and then she can apply it to a real-life situation. So before I just let Emily go hog wild, I'm going to give her an example, and I'm going to show her how I would do it. So she'll watch me do it, and then she'll go ahead and try to replicate that. We're going to be using my Hobart Handler 140. I'm going to be running it all the way at the top. So probably about 120 amps, somewhere in that range. And I'm going to be running it at about 300 inches per minute. We're going to be using E71T-GS flux core wire in 035. A little thick for 1/8 inch material, but it's what I got loaded up in the machine, so it'll be fine. So another thing with flux core you have to worry about is the stick out. This is a little too much. So what I'm going to do is just break it off. It's one of the favorite things about flux cores. You can just break the wire off without having to get nippers out. And I'm just going to go ahead and poke it out 1/8 to 1/4 inch. Stick out is important because you'll get a cold start, you just won't get proper fusion at the beginning of your weld. So I'm going to go ahead and I'm going to set this up into a T-joint. And because I'm not working on a metal table, I've just gone ahead and ground a little piece of scrap. And I'm using it as a ground bar because these aren't exactly long enough to ground with. So I'm just going to set it up there like that. Two more important things when you're flux core welding. You need to have your machine on DCEN, that is electronegative. That means that this is negative, the ground clamp is positive. The other thing you need to worry about is you need to drag. Do not push with flux core. If it's got slag, you drag. Now let's get into welding this thing. So I'm just going to start here at the beginning, and what I'm going to do is I'm going to work back into the edge of the puddle. I'm going to start, I'm going to work my way back to the edge, and then I'm going to start in, dragging. And what I'm doing is just keeping my wire pointed right towards the middle of the fitment. And I'm dragging slowly, watching the puddle build. And what I'm also doing is I'm not having too steep of a drag angle. You know, maybe 5 degrees, 10 degrees, somewhere in that range. And I'm just dragging it along, watching the puddle fill, and grab both pieces of metal. I'm not whipping it, I'm not doing anything fancy. You can manipulate flux core, but you shouldn't always do it. And then what I do is I get to the end and then pull back into the weld puddle. So we'll let that cool down. We have a nice bead profile here. It looks good even with the flux on it. So let's get this crappy wire brush on it and see if that'll knock the flux off. It's still pretty hot. Let's get a better wire wheel and we'll go ahead and knock that down. So because our Chinese wire brush didn't work, we're gonna go ahead and whip out the old wire wheel. Weld profile there. It's not perfect, but it's pretty damn good. It's passable in any circumstance that I've ever ran into. So that's what you're looking to get when you're done with flux core. All right, so there's an up close of the weld. Looks good. So what I'm going to do now is just grab it, break it off, and we can see we have some nice telegraphing going through the bottom. That means we got some pretty good penetration into that weld. Now, Emily's going to give it a shot. Are you ready to do this? She's just going to tack it down so it doesn't move on her. Nope. Hit it and hold it. Nope. Hit it and hold it. There you go. Perfect. All right.
One side?
Yep, just one side. All right. You're pretty confident in what I told you there? Do you have any questions before you start?
Nope, I think I got it.
Okay, so don't get too steep of a drag angle now. Yep, there you go, and try to get yourself comfortable.
A little bit forward and then back, correct?
Yep, so you wanna start there and then whip back in to the edge of the material, and the reason is you want to fill that crater. That can happen when you first start. You don't want to get a cold start. That's basically the reason, is you don't want a cold start when you first start a weld. Hold it and drag it. There you go. Turn your angle down a little bit. There you go. Yep, you knew what to do. Slow down a little. There you go, went back in, nice job. Very nice. Let's take a peek. Looks pretty good so far without grinding the slag off. Why don't you grab that wire wheel and knock the slag off for us and let's see what you got. So it looks to me like you were doing pretty good here. And like I said before, this is where I told you to slow down because you were just going too fast. So
that
basically,
was too high.
Yeah, basically it was just a speed issue because you were just going too fast the whole time. So really you wanted your whole weld to look more like this. Yep. This is just all too fast in here. And then that was that bad start you got. That's not really a big deal. Why don't we do another two and see how it goes from there. So Emily's gonna go ahead and set herself up another T-joint. So we have some ground for butt joints and some ground for T's. So she's gonna do a T and then I'm gonna do a butt joint, show her how that's done, and then we'll go from there. So Emily's got her T all tacked up, a little crooked, but that's okay. It's not a fabrication test, it's a welding test. And she's gonna go ahead and run that thing out. The first thing you need to fix is your stick out is too long. So break that little piece of flux core off and then stick it out to about an 1/8 inch, 1/4 inch. There you go.
Too much?
Yeah, it's all right, it's about a 1/4 inch. All right, so go ahead, do what I showed you. All right, so it looks pretty good, a lot less mistakes on this one. Go ahead and wire wheel that up. That's a lot better than the last one. So at first it was okay, a little fast there after you got past like the first 1/2 inch, a little too fast. Then it was pretty good right there, again, a little too fast. And then right here throughout the rest of the weld, you had the gun. You must have had the gun, I didn't catch it, but you must have had the gun too much like that when you really should have been pointing down more. You should have rolled it down. So you had it up in there like this, you really wanted it down like that. But pretty good. You know, nice job there. Let's run one more on the opposite side and see how it goes. Whenever you're ready. Slow down. There you go. Getting some more of a drag angle. Get a little closer. A little closer. There you go. Get a little further away, just too close now. There you go. Nice. Very good. That was probably your best one yet. Good looks. Yeah, you don't want to get your cord caught up in the wire wheel. That won't be fun. Yeah, you can see how it was a little bit better. Still a little fast right in this section. Right there was, from here to here, it was damn near perfect. And then at the end, what happened was you just got your gun a little too close to the weld. But other than that, good job. That's really good for your fourth, I think that's your 4th ever, maybe 5th ever flux core weld. So that was very good. So if you're watching this video, I assume you're new to welding. So the next thing I'm going to show Emily how to do is do an open root weld using a copper backing bar. Now this is a really good trick if you're new to the game and you're not really confident with your open root skills because an open root weld can be kind of intimidating. So this is a good way to get around that. If you can access the back side of whatever you're welding, you can just clamp one of these copper backing bars on there and get a fully penetrating, nice looking through and through weld pretty easily. So that's what we're going to do now. I'm going to go ahead and I'm going to weld this fitment up here. You see it's a pretty decent sized gap, but this isn't uncommon, especially in the welding repair realm. I run into gaps like this all the time because either bad fitment by me or just that's what's required because I had to gouge that much material out. So often, if I can fit it, I will stick a copper backing bar in there just because it makes it quicker and easier for me. This old Hobart has served me well over the years, and she just keeps on welding, so we'll keep on using her. But we'll go ahead, flip this bad boy on, and we're gonna get this thing tacked out. She moved a little. So as you can see, we got a pretty nasty gap still, but let me show you up close why this works and how it works. Because copper is a dissimilar metal than steel, that's the reason this works. And again, you want to have a drag angle, and this time I'm going to use a bit of a whipping motion so I can tie in all pieces of metal. And you would do the same thing if you had a steel backing bar. The difference is this is not going to stick once we're done welding, because obviously you can't weld steel to copper. Again, I'm just maintaining a steady stick out. I'm just weaving back and forth between the two pieces of material and grabbing both of them and making them one piece of material. So I think we've successfully combined our two pieces of metal here. Let's take a look though. As you can see, it doesn't stick to the copper backing bar. And there's the back side of the weld. Let's clean that up so I can get you a closer look. So that's the back side of the weld right there, and it doesn't look half bad. You can see I made a mistake there at the start. That was a cold start, and that's what I was talking about earlier, and that's what you're trying to avoid by whipping back in, and I didn't do it this time. So, as you can see, I faced the consequences of that. However, the rest of the weld looks pretty good. Let's flip it over and get the flux off of that. So as you can see, we have a nice weld profile front and back. And if you look down it, you can see it's bumped up just a little bit on the bottom and on the top. So now these two pieces of metal are now one. So that's what you're looking for when you weld certain things, is a fully penetrating weld, which we were able to achieve with the use of a copper backing bar. And as you can see, the flux just stuck to the copper backing bar. I can go ahead and clean that up. And now this bar is ready to use again. So Emily just asked me a really good question. She asked me, well, what if we're going uphill? Do we drag it then? No. You have to push when going uphill, and that's the same with stick welding. I know I said if it's got slag, you drag, and I mean that in a flat or a horizontal position. But when running uphill, you always need to push, and you need to maintain a pretty straight-on angle, but you can get a little steep with it if you have to, if the situation calls for it. That's one of the more difficult things to explain without showing, because you really have to read the puddle in order to know when to do what. Yeah, Emily, you ready to do an open root? Yep. Think you got it?
Maybe.
All right. Go ahead and tack it together, and then go ahead and do exactly what I showed you.
You tacked it like this, and then like that?
Yep. Slow down. Let it fill. There you go. You need to get a little closer. That's good. Tack. Okay. Now go ahead and do the opposite side.
That was a little difficult.
Yeah, you don't have to, don't work it back and forth as quick. Just stay in it and just know that it's not going to fuse to the copper. I know it's kind of confusing because you're used to fusing to anything you weld, but it's not going to fuse to that copper.
Which is why it just came off.
Yep. Go ahead. Slow down. Slow down. Stay in the puddle. Now get in the middle. Get between the two tabs and let it fill. It'll fill. There you go. Good. There you go. Now you got it.
Okay. So be more in the middle, and it will eventually come together.
Yeah. So you can see it'll fuse because it's not going to stick to this piece of metal. So if you were to do what's called a D11 welding test, a D11 would be an open root with a backing bar, but with a steel backing bar, and they expect that backing bar to stick. This is more of a field repair technique. I don't know of any weld test that will require a copper backing bar. So the reason I'm showing this to the people who watch my channel is because it's a repair channel, and I'm not following a welding guide or a welding procedure. So I do anything I need to do in order to make the best weld I can, and a copper backing bar is a great way to do that. Emily's gonna correct one of the mistakes I made, and what caused me to have the lack of fusion like I did right here is that I didn't wire wheel my tacks like I should have. So she's gonna go ahead and correct that mistake on hers. So whenever you're ready. Now move to the other side slowly. All right, now back. Nope, nope, back. Getting over into the weld. Nope, pull towards you. Come towards you. Now you're just sitting in one area building a clump of weld up.
What?
You need to move.
Okay, I was coming back.
No, no,
Nope.
you were going too slow. Yeah, that seems like it got most of it off. Nope, no. Let it build. Oh, you're getting too much into the base metal. Now move. Yep, that's it. Just get to the edge of it. Get to the edge. Yep. Now move in. Slow it down a little. Get tighter. Get closer. Too far away. There you go. Come on. Slow it down. Slow it down. Slow it down, Emily. Slow down. Let that puddle build. Watch it build and then move. Slow down. Go just a hair fast. There you are. Start building. Now move over to the other side. Let it fill in. Now move over. Fill in. Move. Yep. Slow down. Well, you got your puddle. There you go. Now you're getting it. Slow it down. Slow it down, Emily. Stop jumping from side to side. Let it fill and then jump, move. Fill, move. There you go. Watch the puddle. There you go. Now get back into that first tap. Get into that tap. There you are. Let's see what the result looks like once it cools down. Yeah, you can wire wheel it. I say that sucker's pretty hot though. It's burning the damn table.
So should I wait?
Nah, let's go ahead and wire wheel it. It'll be okay. Really need to get my steel table in here. So the top of your bead profile looks pretty good. You were just a little slow here, but the rest of it looks pretty good. It looks pretty freaking good until about right here. This is where you jumped out of the puddle real quick, and that's when I was like, hey, get back in the puddle. Here's a little too slow, a little too hot, but right here is damn near perfect. Let's flip that over and see what the backside looks like. Damn thing goes to the table. All right, clamp it back down and wire wheel that. Right there, you had a little pit, and then right here again, we just didn't tie in well enough. The same thing I did. So it's really not that big of a deal, but it looks really good. That was a good first open root flux core weld. So nice job, Emily.
Thanks.
All right, so you want to try some uphill?
Yeah.
All right, let's do it. So just like the first time, I'm going to give Emily a quick demonstration of how to weld uphill. And basically, I'm just going to go ahead and push it up, show you guys how I like to do it. All right, so I'm going to go ahead. I'm going to start here down at the bottom. Let the pedal build a little bit. And now remember, we're fighting gravity, so it's going to be a little high. And I'm just pushing slowly uphill. Pushing slowly up. Maintaining the same angle, and I'm also maintaining the same distance. Now when I get here to the top, it's going to want to melt, so I just barely touch it, sort of drag down. But as you can see, I made a mistake. I got a little too hot there at the top, and I should have whipped in and out a little quicker, even though I did it super fast in the first place. But let's wire wheel this and look at the result we got. Oh, look, you see it just wants to come right off, but that's always a good sign. It's not the perfect uphill weld. My angle is probably a little bit off, and we have a little pinhole there at the edge. But that's basically how you want to do it. You want to maintain an angle, you want to maintain a speed, and maintain your wire length, and you want to push it uphill. So I'm going to give this one more try, and then I'm going to turn it over to Emily. So I'm going to put a little less angle on it this time. I'm just going to push it up. I'm still wanting to get caught up in my tip. Probably need to change the tip here pretty soon. Letting it wet in, and I'm just moving up steadily. All right, now we're getting to the top, so I need to be quick. There we go, it was a little bit better that time. So you can see the difference changing my angle made. It made it a wider bead profile. But let's wire wheel that and really see what we got. So it looks pretty good. You can see we have some sort of anomaly right here. I'm not really sure what happened there. That could just be something in the wire. But that's a pretty good uphill pass. We don't have any undercut, no defects. So that's passable in my eyes. Right here towards the end, that could have been done better. We have a little pinhole. We also have a little eat out of the weld material here. But like I said, that's passable on a repair. All right, Emily, you think you're ready to give it a try?
Yep.
All right, go ahead. Let me know when you're ready.
Good.
Hit that trigger. There you go, man. Yep, you're doing pretty good. Push it up. Oh, got too close. So clean the tip off. Keep what you're doing. Nope, get back off. You keep getting too close with it now. Just don't get so close. That's the only mistake you're really making so far. So up until this point, the only uphill welding Emily had been doing had been stick welding. So I think she was applying that knowledge to what we were doing here. Alright, nice. So you should have just whipped it a little at the end, but that looks like a pretty good weld so far from what I can see. So let's wire wheel that and check it out.
It's hard.
Yeah, it's not super easy, but you did a good job for your first one. Good wire wheel that thing out. So it's a pretty good weld there. Little spots where you were fast, little spots where you were slow. But other than that, I mean, it's pretty good. Why don't you run another one right next to it and try to get it the whole length in one weld, okay?
Good?
Yep, go ahead. You're doing too much of an angle, but it's going pretty good. So just keep it going. There you go. Now whip it again and get to that top. Oh, that's all right. It's one of those mistakes that's hard not to make. I do it all the time. But go ahead. That looks really good. Go ahead and wire wheel that, and we'll see what it looks like. Pretty good. I think with focus, you can see. Pretty good. Looks pretty good. You were a little fast right here. You see it a little too fast. Right here was a little. Actually, that wasn't too bad. And again, you just had some spots where you're too fast. Right here was pretty decent. I think if you just worked on it a little bit longer, you probably get that down pat. That was our little how-to flux core weld tutorial. If this helped you out today, like, subscribe, share. If you didn't like the video, well, you know what to do. Go fuck yourself. And if you really like the video and you want to support your boy, go buy a hat, buy a t-shirt, go to meltonmetal.com, do what you can. All right, guys, until next time, I'm Melton Metal Anthony. This is my assistant, Emily. We'll see you later.